pyNastran first impression. To be honest, this was not a deep analysis of pyNastran. It started with simple curiosity. Running the GUI. Opening a sample file. Clicking through geometry and result views. Watching terminal logs scroll by. And then a strange feeling arrived. What era of engineering is this from? The first surprise was how lightweight it felt. A tool connected to the enormous world of structural analysis. Yet smaller than expected. At first I wondered. Does this actually contain the solver too? The answer was no. pyNastran seemed less like a solver. And more like a bridge connecting data. Geometry. Visualization. And results. Then another thought appeared. Perhaps this is not the solver itself. Perhaps it is a window. A window looking into a vast analysis world. A place where input files, result files, and engineering knowledge all meet each other. Even the name carried an old feeling. Nastran. NASA. Structural analysis. Suddenly I imagined punch cards. Mainframes. Fortran. Batch solves. And calculations that ran for days. A different era of engineering. But the strangest thing was that the world never disappeared. Recent commits were still appearing. On the pyNastran GitHub repository. Somewhere in the world. People are still building BDF files. Reading OP2 outputs. Reviewing results. And connecting everything through Python. An ancient engineering civilization. Still alive. Python and GitHub seem to be opening doors. The analysis world once felt closed. Massive solvers. Expensive licenses. Internal workflows. Dedicated workstations. But tools like pyNastran feel different. Almost like translators. Between the closed world of analysis and the open world of software development. And yet, something felt uncomfortable. Input. Calculation. Results. Revision. Calculation again. The workflow is powerful. But over time, have we started paying more attention to contour plots than to understanding why they appear? This is not a criticism of FEM. FEM is one of humanity's great engineering achievements. But another question remains. How does a person truly understand what the results mean? That question still feels unfinished. My thoughts drifted back to hand calculation. Experienced engineers always return to load flow, equilibrium, deformation, and physical intuition. Hand calculation is not simply an old method. It may be the deepest sense of understanding a structure. From there, the thinking returned to HEM. Not replacing FEM. Not competing with HPC. But connecting. The intuition of hand calculation. The power of FEM. And a new layer that observes change itself. Relation weakening. Micro-opening. State transitions. Local instability. Space emerging. Nothing is finished yet. There is no HEM solver. Only prototypes. Thought fragments. Seeds. Spaces. Relations. And a growing thought archive. Perhaps Shardhana is not trying to build the definitive solver. Perhaps it is simply exploring a different path. And for now, it is still walking near the entrance of that dream.